Hello everyone. So today we are next to New York Penn Station, New York City, and we're going to record a few things. We're going to talk about several topics in calculus right now. So let's start off with looking at the chain rule and the differential equation. So we're going to look at some implicit differentiation. So let's go ahead and take a look at implicit differentiation. So we're going to do implicit differentials. So we could start off by looking at an example like xy plus 2x squared plus y equals 1. In order to take the differential of this, we just take the derivative of all of those, and when we have two variables multiplied by each other, we're just going to use the product rule. So in this case, if we derive xy, so all we have to do is take the derivative of the first, dy over dx, in terms of, x, so that's going to be 1, times the second variable, and we're going to add, x times the derivative of the second, in terms of dy over dx, so that's going to be dy over dx, plus, and then we're going to take the derivative of x squared over here, and then we're going to get 4x, plus the derivative of y, that's just y prime, dy over dx is equal to 0, So now what we have to do over here is we have to factor all of the derivatives that are located in this equation. So all we have to do is bring those terms together. So we have to bring x dy over dx plus dy over dx together, And then we bring everything else to the other side. So we're going to put negative 4x minus y on the other side. And then over here we can factor dy over dx. So we're going to get dy over dx times x plus 1 is equal to negative 4x minus y. All of that divided by x plus 1. So we're going to divide that by x plus 1 over dx. So then we're going to bring everything else to the other side, since we don't need all of this over here. So we don't need negative sine xy and sine x, x cosine x. So we just bring it to the other side. How about that? So we get sine x, sine x, sine x times y. There you go. Sine x times y. See? So right here.
Times y?
Yeah. So this is.
Are you a genius?
No, I'm not a genius. You're a genius.
Only thing I think I saw was implicit. I don't know nothing about.
Oh, implicit.
Okay, yeah,
Right. So it means that you don't see y equals something right away. So you have to find out what y equals. But you gotta find dy over dx over here. So we're trying to find the derivative of this entire. Yeah, he's my grandpa.
Oh.
Yeah.
That's grandpa?
Yeah, that's grandpa over there.
Hey, man, I seen this and I just was kind of fascinated on Quizit. I don't know the real word I'm trying to look for, but I just had to come over here and see. But you are a genius. And grandpa know more than you, don't
Oh, definitely. You got it. Okay, so we're going to continue by taking the differential, of this equation. So we're just bringing everything
to the other side, as you can see, and then we have minus sine x cosine x, and then we have plus y. So right over here, all we can do, since we factor out the terms from the dy over dx, we can just divide everything by that, and we find the differential equation. So dy over dx is sine x times y minus sine x, minus x cosine x plus y. All of that is
going to be divided by cosine x plus x. Look at the chain rule. So right over here in the middle of the street, in New York City, we're going to look at the chain rule. So let's take a look at, for example, y is equal to sine, of e of x, times x. And then we're going to take the first derivative of this, this function, y equals f of x. So in order to do that, we have to apply the chain rule. So what we do is we take the derivative of the inside first, and then we take the derivative of the entire thing as a whole. So it's like a composition of functions. So first, let's take the derivative of the inside. But as you can see, e of x is being multiplied by another variable, by x. So that means we have to use the product rule again. So we have to find dy over dx over here. Dy over dx is equal to, the derivative of the inside is going to be, ex times x plus ex. So the derivative of ex is just ex times ex. We're going to add ex times the derivative of x, which is 1. we get this, and then we're going to multiply all of that times the derivative of the entire thing. So we're just looking at sine of whatever we have. So when we take the derivative of sine, we know that's going to be cosine, right? Remember this unit circle over here. We have sine over here, we have cosine over here, we have negative sine, and then we have negative cosine. When we differentiate, we go clockwise, so it's going to be like so. So if we have sine and we want to differentiate it once, we just get cosine. So we're going to get times cosine of ex times x. And this is going to be the first derivative of this function. You could keep going, and you could take as many derivatives as you want, but I don't have time for that. So,
Are you a teacher?
yeah, I teach, of course. There you go. All right, so now we're going to look at something very special. So I've been posting videos on Richard Feynman's methods of integration. So today we're going to look at some integrals first, and then we're going to show, okay, Richard Feynman's methods of integration. So let me see. Okay. So let's go ahead and take some indefinite integrals, okay, over here. So we're going to look at indefinite integration. Indefinite integrals. So all these indefinite integrals are just elementary integrals. So we're going to look at, for example, the integral of x squared, fairly easy, x to the 3 over 3, plus, okay, this one, integral of 3 over x, okay, very cool. The integral of 3 over x is actually not, you don't have to apply the same rule we do for exponents. So what we do is, because it's x to the power of negative 1, you can just add 1 and get 0, right? So what we do over here is it's going to be ln, okay, of the absolute value of x multiplied by 3. Okay, and then we're going to add plus x plus c. Don't forget the constant of integration. It's very important not to forget that. So how have you ever thought about, okay, evaluating an expression like this? So when you have a cube root, okay, of 7, okay, plus the square root of 50, and then we add it to the cube root of 7 minus the square root of 50. So can you find the answer to this without using a calculator?
What is Victoria's Secret?
Sorry, what is it?
Victoria's Secret.
It's probably over there.
Alright.
Yeah.
Go straight.
Yeah, just go straight. So let's see. This guy was asking me where Victoria's Secret was. Well, I have no idea. I just sent him somewhere. Well, let's see. So help us out. So let's try something else. Now we're going to try the next one. So that's going to be negative 1, right? But it looks like it's not going to work. So let's see. 1, 0, 3, negative 14. Here what we're trying to do is we're trying to find the answer to this, okay, expression over here. The cube root of 7 plus the square root of 50 plus the cube root of 7 minus the square root of 50 without a calculator. We're just using algebra.
50 would be
There's no exact number for the square root of 50, but it's a decimal. We don't know. So what we're going to do is, okay, use algebra. We're just going to use pure algebra to find the answer without a calculator, okay? But we're already ahead. What we did was we cubed all of this. We raised it to the power of 3. So we multiplied itself 3 times. So that times that times that.
So that'd be 150 and it'll be 7.
So
21, right?
what happens is when you raise this to the power of 3, you get rid of the first term because this is a cube root, right? So you get rid of that term, and then when you raise this to the power of 3, you get rid of that term as well, right? So, but we're already past that. We use Pascal's triangle, which says that, okay, 1 plus, and then we got, okay, 1 plus 1 is 2. So we do 1, 3, 3, 1. So we use the third, okay, exponential expansion. So we're just going to do this third line, and then what we did was we used a whole very complicated expression, and we simplified.
x3 plus 3x
3x
plus 14
minus 14. I got all of this from this.
Okay.
Yeah. So, but that's ahead of us already. But I'm just going to show you that when we find the answer to this cubic polynomial, okay, we're going to find the answer to this expression.
What is this called? The expiration form?
This is the polynomial function, okay? Trinomial,
yeah,
because it's got 3 terms, okay, and it's raised to the power of 3.
Okay, yes.
So I'm using synthetic division to find the answer to this polynomial. As you can see, we just use the coefficients of each term, and so we're going to use 1, right? Now there's no x squared, so we have to use 0. We have to include that.
Yes.
Now we have 3 for 1, and we have negative 14. Now we're just going to bring this down. 1 times 2 is 2. 2 plus 0 is 2. 2 times 2 is 4. 4 plus 3 is 7. And 7 times 2 is 14. Look at that. 14 minus 14 is 0.
Yes.
That means 2 is the answer to this, okay, crazy expression.
Function, yes, because when you put 2 into the 3 and put 2 there,
Right, and then you get 0. There you go.
Exactly.
It makes the expression true.
Oh man, you're great at your job, man. What
Thank
do
you,
you
man.
do?
Oh, I'm just a college student. I'm going to college soon.
Oh, fucking awesome, man. You look like a professional.
Thank you, man.
All right.
Yeah, I'm trying to make some money because, man, college is expensive as hell. Okay, so, yeah, man. You don't have to. I see that, you know, you might need the money. So,
No,
I mean,
I don't, man.
oh, man,
I
thank
don't
you.
have no lower bills, but awesome,
Thank you so much,
man. You
man.
broke
Okay.
that down so easily.
Yeah, it makes it so easy, right?
Yes, I understood that, man.
Now. So determine all functions from I don't know z to z.
You can write it, yeah. Okay, this problem looks like something I have never done before, but well, let's see how it is. It's function. Theta function. Holy crap.
No, it's not that. Determine all functions which is possible.
Okay. All functions.
Yeah,
that are
which
possible.
is success this equation.
Okay, very good.
It's integer. So and a and b. Yeah.
And the Z, yeah.
This function is from
Oh, let's see what that means. Hey, how are you? Subscribe to my YouTube channel, Marin Maths. We do maths for fun, okay? You don't have to go to college, pay $50,000. That's nonsense. We teach it for free. Yeah. Sorry, what is it?
Why spend $200
Oh.
for credit at Columbia
That's not that much. Yeah, I'm going to NJIT, New Jersey, Newark. Yeah, of course. But he gave me this problem, so I'm going to try to solve it with the best of my ability. But let's see what we can do here. So he's saying, okay, find all functions, right? That satisfy these equations. F of ZA. Right?
2a.
Right, 2A, sorry. So that's F of 2A.
2 times it's 2 times
2 times F of
value.
F of
Yeah.
B. Okay, so F of 2A plus 2F of B equals to F of A plus B.
So it's from this function. Sorry, I'm not speaker of English, so
I will try to
integer to integer. It's function.
Oh, that means it's
Yeah.
a set of all real numbers.
Yeah.
Okay. Very good. Real figures. Okay, very good. So this is A and B belongs to C. So A and B are fixed. Okay. Now let's see what we can do. So we have to find the function. In terms of A, C, right? I mean, A and B.
It's 2 times f of a.
Well, let's see what we can do. Maybe we could take an inverse function. Maybe we could take an inverse function, but what could we do? Let's see. Maybe say f of a plus b is equal to the inverse function of f of 2a plus a plus 2f of b. And we could say that. Okay, we're just taking the inverse. We're just taking the inverse function. So f of a plus b is equal to f equals 2a plus 2f. Very good. Let's see what we can do. Trying to find a function. It's gonna be in terms of, so how do you want the function to be? F of a equals something? No. Only
Green, the function.
right, it's one. Oh, so
one.
a linear
So
function.
It will, yeah, it will satisfy because now
Right.
it will be good, but for different,
So
it
exactly.
will go extremely high or extremely low for daily.
You're right.
Enough.
So let's try at 1 degree. So how about we just try x? F of x equals x. We do that. F of x equals x. F of a plus b equals a plus b. Okay, so we know that
Maybe a times x plus b.
a times
X plus b.
x plus b.
Some linear function.
So a times x plus b. Something like that, right?
Yeah.
Maybe it could be a linear function in terms of a b.
I mean,
Oh, so a times x plus b. Oh, I get it. Yeah, so I mean, well, we could try that. F of x is this.
but then it's another a.
Yeah, it's an x value. So we could try that. Let's try that. So let me just erase this so I can. So if we try ax plus b, well, let's go ahead and substitute. So this is going to be a times 2a, okay, plus b, right? That could be plus 2 times, okay, a times b, right? Plus b. And that's going to be equal to f of a plus b. That's going to be a times a plus b plus b. And then f of a plus b plus b, we have to substitute that. Maybe just do that. Yeah. There you go. Absolute value.
Yeah, so we have to do also proof. Will or it won't.
Will or will? No.
Yeah.
So how do we do the proof now that we have this? How can we
Because it thinks about something. So
Because we use a linear equation.
let's try to go.
Wanna move it?
Yeah. we can.
Yeah.
Let's try to go a different way.
There we go.
May I erase it?
Yeah. Let me get it. Давай.
Okay. F of A.
And then it's the original product. F of 2a plus a 2 times. Very good.
B.
Yes. And then it was equal to f of a plus b. There you go. F was 0. Oh, okay.
We're supposing that A equals 0.
Okay. Oh, okay. We're this.
We're trying if it will simplify something or we can notice something.
Very good.
It's a common idea when you are trying to solve equations.
So if we suppose a is equal to 0, this is b.
It's yeah.
B.
Sorry.
So, no, that's okay. Plus 2 times f of b equals to f of x b.
But that's hard to destroy everything.
I know.
You have this when you're trying to graph it. You move it from here to here. Here we have to move it here. And we have to move it here somewhere
So
there.
you have to
So-
test points.
Yeah.
So you have to make a table of values in order to test the points, right?
No, but I'm thinking if it will say that it will be if to get something like that maybe.
Okay. Oh, okay. So to make a generalized statement.
But I don't know right now, so
But we have to start off from a
one function will get this equation. So it's
Álgebra.
álgebra, geometría, trigonometría, estadística, cálculo.
Acabé, porque yo sé lo que un 16, un 19, 32. En Miami me da un examen, me quemé en inglés y todo y no pasé porque yo era mecánico industrial.
No me digas. Suscríbase, Marin Maths. Nosotros hacemos videos de YouTube gratis por divertirse. Por
¿Cómo?
diversión.
No me digas,
Sí, señor.
el GD,
Cualquier cosa. Nosotros le llevamos con cualquier cosa.
el GD
Sí.
gratis. ¿A dónde?
Claro, no, en YouTube, suscríbase. Marin Maths. Tiene que ir a internet, YouTube. Sí, no, facilito. Nosotros lo hacemos fácil y sencillo para usted.
No, a mí me gusta ver frente al público.
Ay, frente al público. Sí, sí, sí.
Porque así hay comunicación.
Correcto.
Pero cuando tú lo haces solo, así que tú ya solo.
No, sí, tienes razón. Bueno, muchas gracias.
México.
México, Colombia.
Parcerito,
todo
papá,
bien.
cabello, hermano, que iba a
Dale,
Colombia,
órale, mi
hermano,
cuate.
Cali.
No, Armenia.
Oh, Armenia, el mejor café.
Claro, sí, puro
Hermano,
café, hombre.
Sí, hermano, que vive la ciudad cafetera.
Sí, hombre.
Me quedo en Santa Bárbara, parcerito.
Gracias, hombre.
Para el
Muchas
camino.
gracias. Análisis.
Yeah, it's real
Oh,
because
holy
I'm
crap.
attending to studies level in high school class. So it's,
Really?
Yeah.
So this is real analysis.
Yeah.
Oh my God, this is what I've been looking for, but I haven't even started to study it. So you're doing what you're doing, but it's not really that easy. Okay, when you don't have the experience to do it. But we'll try to find some function that satisfies this. Satisfies
Yeah, so-
this statement.
It's not that difficult. You're telling me to eat.
I really thought it was like an algebra 2 problem, like, you know, composition of functions. It doesn't. Okay, you have a problem? The easiest. Subscribe to my YouTube channel, Marin Math.
Men då får man kanske den välja.
We're doing math for fun. Yeah, math and physics. Where are you from? Italy. Parli italiano? Sì, da dove sei? Dove? Svezia? Ah, molto bene! Piacere! No, non conosco Venezia, ma io sono di Colombia, di Sud America. Sì. No, stiamo facendo con la matematica con tutti. Sì, lui è di Polonia. Sì, lui è venuto qui per fare qualcosa di matematica, analisi reale, si chiama analisi reale, è una materia molto complessa, surreale. Come si dice? Surreale? Analisi surreale?
Reale, vabbè, non reale. Sì, l'opposto di reale.
Come si dice?
Teorica.
Teorica, sì, è una teoria. Lui stava vivendo un problema per darmi, lui vuole darmi un problema per sì. Siete di Venezia anche? Ah, molto bene, io sono di Colombia, ma io ho imparato l'italiano a mia scuola perché è una città molto italiana, ci sono molti italiani qui, si chiama Sicopus, sì, si chiama Sicopus. Loro mi hanno insegnato italiano molto bene, mi piace molto imparare le nuove lingue. Non è perfetto, ma...
È meglio di noi, guarda.
No, io non credo.
But it make it the right one? Yeah. You have to prove that.
So devi andare a YouTube e devi scrivere Marin Maths e poi potresti incontrare. Sì. Si chiama Marin Maths. YouTube. Mi scusa? Sì, io sono su YouTube e io faccio molti video di matematica, calcolo.
Il tuo lavoro cosa fai? Sei studente ancora?
No, io sono della scuola dell'università.
Quindi New York?
No, io vado a New Jersey, Newark. Sì, conosci Newark?
So che c'è l'aeroporto.
Cose. Oh, ok, ci conosci. Come ti chiami? Claudia. Un piacere, mi chiamo Juan. Valentina, piacere, mi chiamo Juan. Quindi lui sta facendo un problema molto complesso. Non capisco. Cosa lui vuole incontrare città?
Java is AD with C, and you have to prove that it's the point when the curve line will cross.
So you have to prove that K is a point where all lines will intersect. Oh my goodness. Okay, this is a tough problem.
This is the easiest one.
Is it easy?
Yeah, it's easy. It's very easy.
So how do you prove it? Well, let's see. What is this?
I can give you a 20,
One, two,
but
three, four, five, six. It's a hexagon.
this point will be here. And right now when you're
Right.
I don't know if now it will be correct.
what's this over here?
Don't
This is
think it will be.
K
K is a point when this closed from the definition, and that's the test. That K is, belongs to
BE. What's BE?
BE
It's this line, right? So K is the point B. That's true.
You can also suppose that, I don't know, L M, and prove that area in the square bracket I will mark the area.
But KLM is what?
It's a triangle.
It's a triangle.
So this point is,
So this is an actual triangle, right?
yeah, you have to prove it. It
Oh,
gets,
see you next time. Arrivederci, sì, piacere, grazie per il visita, arrivederci.
you have to prove it that the area of that triangle is equal to 0. It will prove that
So you have to prove
K,
that this triangle is 0 in
Yeah.
what sense?
it's on one way.
The area.
Yeah, the
Oh,
area.
the area has to be equal to
Yeah.
0. Oh my goodness. Okay.
It's one way.
It's
So
eight. So let's see. So the area of this triangle.
you can yeah.
Yeah.
So this theorem, you can think about how to prove it.
Damn. This is real analysis too, right?
No,
No?
geometry.
Geometry. Just regular geometry.
Regular geometry.
The high level geometry. Sort of, maybe. Nothing is high level in Poland, okay?
11th grade. It was 11th grade.
Really?
Yeah.
We've never taught that. Like, you know, the one class we take in high school for geometry,
Yeah, but-
we only go up to like tangent lines.
It's
That's
the
it.
easiest problem when I can.
Colombia.
It's the
Suscríbase.
first, it's the first problem, and now you have the harder.
Send me those links to my YouTube channel.
But it's important.
Mania. Donde?
Also, you can think about it.
I'm gonna think about it.
There's also
¿Cómo es?
cortando los triángulos.
¿Cómo? Él me está preguntando un problema que está por detrás del tablero. You wanna pedir el elemento?
I don't remember the theory.
Mendeleev's theorem.
I would need to revise, but
I'm gonna revise all of that. I'm gonna learn all of that because I haven't even touched that.
it's
So
the same equation because A, B,
B,
C,
okay.
D, E.
Yeah. They're all points.
So it's the same equation, but it says that.
Well, you know this angle has to be the same. That's for sure, right? Easy.
But it says that.
Don't forget. Don't worry about it. Just send it to me on the comments. YouTube channel. Marin Maths. Suscríbase a Marin Maths. Because the thing is, we've never learned real analysis in high school.
Seriously?
Yeah, we don't. To some extent.
But you
Okay.
have many interesting courses. For example, I don't know, Stanford pre-collegiate courses.
Stanford.
Yeah, I've taken one.
So because I'm gonna study mathematics, applied mathematics and applied
I
physics.
would rather study computer science.
Computer
but-
science, really?
Yeah.
But what are you gonna do in college, in university?
I would rather try apply to Cambridge or
In England.
MIT. Yeah.
In England, yeah. Those are tough ones.
Yeah.
You could get into it. You know, if
Yeah, but-
if you know real analysis, I think you will be fine. Okay. Sí, señor. Muchas gracias, hombre.
I can.
Mucho gusto,
also,
Juan. Jorge. Gustavo.
Hello,
¿También Colombia?
You have, for example, many.
De cerquita,
Modena is not too bad.
Yeah, but that's the same.
No, okay.
I'm gonna think about this problem too. It's all recorded, so I'm gonna think about that. I've never seen this. I mean,
So-
honestly.
Use Menelaus to that, and it's easy. You have only think which point you should take, and if you get this only points, you'll get it.
Right, because it must be, okay, you're just trying to move all those points to one point, and then you're saying all those points are on the same plane.
You're trying to pick some points and make a triangle with that, and use Menelaus theorem for the triangle, but if you're going to be that. I don't know if it's that triangle, because it's possible that it will be just.
I'm gonna think about that. Once I get home, I'm gonna spend some time
so
in
you
real
can-
analysis and geometry, advanced geometry. Now, but you took calculus, right?
Use some harder, very hard integrals. We need to have a basics. So that's why
You're right. Yeah, because for example, in this integral, well, like easy integrals, like integral of x. Yes, that's so easy, right?
yeah, so it's
Add 1 to the exponent, that's divided by 2. That's very easy, right? But then when you have like improper definite integrals, so I'll show you one improper integral from certain improper, okay? Of sine of x.
Pero lo importante es que trae un mensaje.
Now look at this. X over x, voila, goes away. Now our lives is a lot easier because now we can use integration by parts, and that's like, you know,
Y eso que la
like,
pena va a entrar.
this is the game, you know. Doing integration by
Apenas va a
parts.
entrar.
Not too bad, right? Integral of sine x. Nice with the negative.
Nieto.
So let me just erase this. But that's not the most interesting part of this game.
Claro, yo estoy con él.
Interesting. So what we're going to do, just going to differentiate and we're going to integrate, a tabular integration. And then we're going to use, well, we can use Lia, right? So Lia, you know Lia?
Gracias, lo mismo.
It's the acronym to know the hierarchy of what functions you're going to use to differentiate. So sine of x is a trigonometric function, so a big function, and e is an exponential, so that goes last. So we could take sine x first. So we could say d, we're going to differentiate sine x. Sine x, right? And we're going to integrate e to the negative ex. But if you think about it, it really makes no difference if you differentiate.